Hi, we are Canary in a Coal Mine Designs, and our project is creating a mobile radiation detector. My name is Avish Menon, and I am joined on this team by Zachary Toffness, Nathaniel Soderberg, and Jeffrey Weiss. Our mentor for this project is Dr. Hugh Barnaby, but we have also recently started working with Partha Chakrabarty and Professor James Aberle, as their expertise has been invaluable in refining our design. Our work so far this semester has been on the simulation and design phase, and we hope to get our PCB design finalized and fabricated within the next few weeks. This is to ensure we can complete testing, and if there are any changes to be made, that we have ample time to get an updated PCB fabricated. Our goal is to have a working PCB to present at the end of the semester. And now here's Nathaniel to talk a bit more about our work with Partha and Professor James Aberle.
Hello, this is Nathaniel Soderberg. We've acquired two more mentors in the last few months. The first being Partha Chakrabarty. He is a principal engineer at CFD Research Corporation. He gave us a little bit of advice on what kind of antenna we should be looking for and ways to deal with some of the signal interference at the end, such as using different kinds of filters. He also brought up some issues of timing, like making sure we have enough headroom to account for external delays or if we need to remanufacture anything in case the testing doesn't go as we need it to. He's also offered to help us with some of the physical testing once we get the prototypes actually built. The next is James Aberle. He's joined us a little more recently. He's an associate professor at ASU. He's mostly helped us with the RF related things with our project. Specifically, he's given us a lot of advice on the antenna. He suggested using two oppositely circular polarized antennae to minimize the interference between the two, and also suggested specific PCB thicknesses and materials just to further eliminate extraneous capacitance and inductances within our device. And I think that's all for me, so I'm going to bring it to Zach to talk a little bit about our simulation progress.
Hello everyone, this is Zach. I'm going to talk a little bit about our work in progress for this semester. So we have finalized our circuit schematics for our simulations as well as started our PCB layout for the hopefully final transmitter design. It was decided that we could tighten our frequency range away from that 3 to 7 gigahertz we had originally intended down to about 5 to 6 gigahertz in order to more tightly wrap around the expected resonance for what we're going to be hitting, as well as to make our circuit a little bit more robust and keep it more stable with a consistent output power over the frequency range that we are expecting. This required just changing out a few of our capacitors and inductors in order to have a little bit smaller values on them to bring up our bottom line from our 3 gigahertz to about 5 gigahertz, and then allowed us to just use a simple buffer from our Sawtooth indoor voltage controlled oscillator in order to get the 6 gigahertz out of it using the varactors that we originally intended. So next, Jeff is going to talk about what work is still to be done this semester, as well as some budgets that we have been coming up with for it. Thanks.
Thanks, Zach. So once we get past the critical design review performed by our professors, we'll be able to go into the ordering the parts, the antennas, all the resistors, capacitors, the parts that we're going to need to have the fabrication, and also the assembly of our printed circuit board. The parts total is around $117, and for assembly and patterning, that comes to be around $100 to $150, all dependent on the time frame for shipping and handling. Once we receive our printed circuit board, we'll go into our testing phase, and if that is successful, then we'll be able to go right into the demo. But if that is not successful, we will need to have our printed circuit board reassembled with our adjusted components, whatever they may be. So right now, as it stands, our budget is approximately $217 to $267, and that's for one fabrication and assembly of a printed circuit board. And so we have some work to do, but we're starting to get to the final stretch of this, and it's been a great journey. Thank you from Canary in a Coal Mine Designs.